In this video, we're going to talk about some plumbing terms and systems. All of these terms come from the Uniform Plumbing Code. That is the governing body for plumbing. First is air brake. This is the physical separation, which may be a low inlet into the indirect waste receptor from a fixture, appliance, or device indirectly connected. The air gap would be in this picture down here. Essentially, it is a break so that if you get backup from water, it won't refill and push into your supply here. Next is a drainage air gap. This is the unobstructed vertical distance through the free atmosphere between the lowest opening of any pipe, right here. Plumbing fixture, appliance, or apparatus conveying water to the flood level rim of the receptor. There's another example of an air gap here. You should never have the head of a faucet or sink down inside the sink. Basically, if this overflows, you don't want any sort of dirty or contaminated water getting back and back feeding into your water system. Next is area drain. This is a receptor designed to collect surface or storm water from an open area. This is basically what you'll see in like outdoor areas. You'll have either some sort of concrete or stone or brick or something, and it'll be slightly angled to where it will feed into this area drain. Next is backflow. Backflow is a flow of water or other liquid mixtures or substances into distributing pipes of potable water supply from any source other than the intended source. So backflow is if you get backup into, if you get a clog or something and you keep adding water, it's water going the wrong way. Backflow preventer. It's a device meant to prevent backflow into potable water system. So this is a backflow preventer here on the right. So typically, water will come this way and it'll push up. There's like a spring in here that'll push up and keep flowing, push up in here, keep flowing. And then if you get backflow, water will push the opposite way and it'll push this valve down. And there's usually two valves, so because you'll have a little bit, before this thing closes, a little bit of water get into this area, and then this one should close before there's actually any backflow into the water system. Next is a battery of fixtures. This is any group of two or more similar adjacent fixtures that discharge into a common horizontal waste or soil branch. So that would be anything connected to this horizontal run here. So all of these are a battery of fixtures. These sinks right here, this is the battery of fixtures here. Next is building sanitary. Building drain sanitary, a building drain that conveys sewage only. And then building drain storm. This is a building drain that conveys stormwater or other drainage but not sewage. So there's usually two different types of sewers. So you have your sanitary that's connected to your house, and that's all of your black and your gray water that typically goes to a sanitary sewer, or if there's like a septic tank or something on site. And then you have your storm sewer. This is the holes that you see in the side of the street against the curb. That's your storm sewer here in the catch basin. The storm sewer needs a lot less treating. So this will go to a different water plant versus the storm sanitary. Next is building supply. This is the pipe that carries potable water from the water meter to other sources of water supply to a building or other point of use or distribution on the lot. Building supply shall also mean water service. Your water will come from a utility company, and so they have pipes underneath the ground, and in typical neighborhoods and whatnot, they'll have distribution pipes underneath the roads, and then they'll tie water into the water meter here for the building, and then from there the pressure will push it up, depending if it's a low rise or a couple of two-story house. Sometimes though in high-rise buildings they'll need a booster pump, so this would be like in the basement usually, and they feed the utility water into that, and then it'll push it up through all the floors. And then here's another a different type. They push all of the water up to an elevated tank, and then from there they use gravity to feed all the floors. And just here's an example of a newer system where they try to reuse and be as efficient as possible with their water usage. So basically, you'll have rainwater collection. You'll have an on-site treatment that they'll use for non-potable water, such as toilets, and try to recycle as much as possible. Next is domestic sewage. So this is the liquid and waterborne waste delivery from the ordinary living processes, free from industrial wastes, and of such character as to permit satisfactory disposal without special treatment into the public sewer or by means of a private sewage disposal system. So like I said earlier, you have your two different types of sewage system. You have your foul water sewage, or you have your surface water, which is road runoff, rainwater, things of the sort. Next, we have a downspout. This is a rain leader from the roof to the building storm drain, combined with building sewer or other means of disposal located outside of the building. So you've probably seen this coming off of gutters. This either goes into the ground and out to the storm sewer. A lot of times on houses, you'll have a downspout that turns and just feeds water into the grass. And lastly, you have a downspout going into a rain barrel, which you can store for water in your yard or what. Next, we have a drain. This is any pipe that carries waste or waterborne waste into a building drainage system. And then your drainage system includes all the pipes within a public or private premises that convey sewage or other liquid waste into a legal point of disposal, but does not include the mains of a public sewer system or public sewage treatment or disposal plant. So the drainage system is everything that is on like the building side. So that excludes anything public utility. In your drain, that's going to be in your sinks, in your toilets, basically anywhere that will remove the wastewater. Next, we have a flush tank located above or integral with the water closet, urinals, or similar fixtures for the purpose of flushing the usable portion of a fixture. So the flush tank is on the back of typically of a residential toilet. You have your flush valve. So this is a valve located at the bottom of a tank for the purpose of flushing water closets and similar fixture. That is down here at the bottom. So you pull your lever that pulls your float ball and arm up, and it lifts your flush valves, and that dumps water into the bowl. Next, we have a flush-emitter valve. This is a valve that discharges a predetermined quantity of water fixtures for flushing purposes and is actuated by direct water pressure. So this is more what you'll see in any commercial building. So it'll have a pre amount of water loaded into the fixture, and then as soon as you press the valve, it'll release the water and refill. Like I said, this is typically on commercial toilets and urinals. Next, we have grade. Grade is a slope or fall of a line or pipe in reference to a horizontal plane. In drainage, it's usually expressed as the fall in a fraction of an inch or percentage per foot length of the pipe. So that's anything that has water in it usually will have some sort of slope in it. Basically, you don't get standing water in the pipes, and so the grade is essentially the rise and run is It's usually like I think 1/8 of an inch over 1 foot is a standard drop. Next is liquid waste. This is the discharge from any fixture, appliance, or any appurtenance in connection with a plumbing system that does not receive fecal matter. So it's going to be any of the liquid waste in a water treatment plant or any non-solid in a water treatment plant. Next is potable water, water that is satisfactory for drinking, culinary, and domestic purposes that meets requirements of the health authority having jurisdiction. So that just means water that's safe for consumption. Roof drains. A roof drain is installed to receive water collecting on the surface of a roof and to discharge into a leader, downspout, or conductor. So this is a roof drain right here that pretty much acts like the same way as an area drain, but it'll collect water here on the roof and safely run it down to the stormwater sewer system. Next is sewage. This is any liquid waste containing animal or vegetable matter in suspension or solution that may include liquids containing chemicals in solution. So this is anything that will need to be heavily treated at a plant. Next is a thermostatic valve. This is a mixing valve that senses outlet temperature and compensates for the fluctuation in incoming hot or cold water temperatures. So this basically will keep the temperature constant in say in a shower. I don't know if any of you have older houses that have the two knobs where it's hot and cold. But if you go and you flush a toilet somewhere and it reduces the cold water amount, then the water in the shower could get really hot. This basically does away with that and make sure that's a constant temperature by regulating the amount of cold and hot water that come in to be the same. It'll just lower the pressure. Next is a trap. This is a fitting or device so designed and constructed as to provide, when properly vented, a liquid seal that prevents the back passage of air without materially affecting the flow of sewage or wastewater through it. And a trap primer. This is a device and system of piping that maintains a water seal and a remote trap. So this is a P-trap. So you've probably seen this if you look under your sink in a kitchen or your bathrooms. Essentially, the water drains down here, and then it'll create a seal right here because you're connected to a sanitary pipe that has gases. So the gases will come up, and if you didn't have this P-trap, or if your P-trap dries out below this line right here, then gases will come in and float out, and you'll get a real bad smell coming out of that plumbing fixture. So the P-trap, anytime you use water here, it'll flow and it'll keep it still. But then you do have, pretty much behind the wall of any P-trap, you'll have a vent pipe, and this will either connect to a series of vents and go out of the roof, or somewhere where you won't smell it, so somewhere high. And then your trap primer in remote areas where you have your P-trap. You have your P-trap here. You have a trap primer that will either connect it to another water source that is constantly used, or sometimes they're electric to basically to refill water in here every so often. Keep that water from evaporating below the elbow right here. So next is the vent. This is any pipe provided to ventilate a plumbing system to prevent trap siphonage and back pressure, or to equalize air pressure within the drainage system. So with any plumbing system, this is your sewer, but to equalize pressure, so it's not just always sucking air down, you have a vent right here, so it can release pressure. So you have sewer gas going up, bring in fresh air, it won't create a vacuum. All right, so that is it for the slides. Next, let's take a look at the plumbing systems. Domestic water, sanitary, and vent. This is a picture of inside of a kitchen before the drywall gets put up. So basically you have your domestic water, so all these copper pipes, this is all supply water coming in. You can see the stub outs right here. We'll talk about stub outs here in a minute. You have your sanitary and your vent. That's going to be these black lines here. So You'll have a sink here that will go into these PVC pipes, and it'll vent out the top and flush the black and gray water, I guess in this instance gray water, down to the drainage system. Next, we have piping stub outs. Stub outs are essentially there for future use. It's because it's a real big pain to get in the wall and repipe if you need to add something. So a lot of times I'll add up top above the ceiling stub outs where you can hit with either a vent or a sanitary or even supply water, and in unfinished out areas because I don't know what may be going in that area later. Next is water heater. So water heaters are, you feed cold water into them, and then you have either electric or gas heater here, and this will heat up water to provide for sinks and sinks, showers, and whatnot. And this one is in the break room, so it's a relatively small one. If you've seen them in your house, it's probably 5-6 feet tall. It creates a lot of hot water, but this is more of a targeted, just for a break room. So it doesn't need to be huge, because if people are just using hot water, to wash their hands, maybe a dishwasher or whatnot. Next, you have your hub drain and a trap primer. So the hub drain is this pipe underneath here, and this is where multiple things can feed into and drain out. And your trap primer right here will slowly drip water or release water every so often to keep the P-trap attached to this hub drain full of water. Next, you have condensate drain piping. So we talked about these units with the mechanical. This is like the spot cooler. This is if you have a server room or something small and just need to keep it cool. But then anytime you have refrigerant creating cold air, you're going to have condensation. So you'll have a condensate pipe, this white one right here, run out and into a drain. It could run into this hub drain up here. Next, we have the sprinkler and cold water mains. This is where the water utility comes in. The sprinkler is this red and black pipe. This will feed the sprinkler system, part of the fire alarm system. And then you have your cold water mains, which is where the water comes in from the city, usable water for toilets and showers and whatnot. That's this white pipe. Next, you have urinal, wall-mounted, and floor-mounted water closets. So these are your standard or your typical toilets in a commercial settings. Just mounted to the wall. This is just mounted to the floor. Next is a floor drain. So these are drains in the floor, essentially for backup or emergency. So if a toilet overflows, you're not getting water run out into the hall. Hopefully, your floor should be slightly sloped to drain into this floor drain. This will be anywhere where there's water, so janitor's closet, bathrooms, kitchens, labs, anywhere where there's going to be running water, there should be a floor drain for backup. Area drain and scupper. So your area drain is right here. This is like a roof drain. And then your scupper is right here in the wall. This is like an overflow, because you have your parapet going up, and if this gets clogged up with leaves or something, you'll have this scupper as a backup. So if the water gets up to here, it'll start overflowing. If you didn't have scuppers, you think about it, you have a 4 or 5 foot parapet, and if it rains a whole lot and there's no outlet, if the drains get clogged, it'll essentially turn into a giant pool, and water's really, really heavy, so you can't have that much weight on a roof pushing down over the entire footprint of the building. Stormwater piping. So this right here is connected to your either area drain or roof drain. They're basically going out to your stormwater sewage system. All right, so that is it for the plumbing terms and systems. Once again, there will be a quiz for that coming up, and I will let you know.